Hello everyone, I am Olalekan Sowunmi, an educationist. I teach mathematics. Today I would like to teach algebraic fraction. You may ask, why algebra? Well, many students don't even know whether it's important to study algebra or not, including you that is listening now. Seeing x and y seem to be a waste of time, p and q seems to be too cumbersome for us at times. We just want to see numbers, but alas, it's algebra. We've got to see letters, and they are representing numbers. But listen, apart from the fact that algebra helps one's logical thinking, we can't undermine its importance in technology as well. Numbers are used to represent symbols which are combined based on set rules. When you click a character on your keyboard, when you press a number on your phone, or a leading on your remote and the likes, those characters are nothing but strings of symbols used by computer programmers. There are other wide areas where algebra is useful, including in sports, daily routines at home, and even in offices. All the guesses we make, you know, in your kitchen you make use of algebra. To know the amount of salt you're going to put in that rice is based on unconscious calculation that you have made. You have represented a lot of things to make it work for you. And so I hope at the end of this lesson you will be able to identify and simplify algebraic fractions. Alright, let's proceed to the definition of algebraic fraction. So what is algebraic fraction? An algebraic fraction is a part of a whole algebraic expression represented by a pair of algebraic terms. As seen on the slide, I'll define it again. An algebraic fraction is a part of a whole algebraic expression represented by a pair of algebraic terms. You may be wondering, what does this whole thing mean? You know what an expression is? An expression, for instance, let's say 2x minus 3 is an algebraic expression. 2x minus y is an algebraic expression. When you divide this by another algebraic term or another algebraic expression or a number, you have what we call an algebraic fraction. We shall explain it further in the next slide. Okay, now let's buttress our point on the definition of algebraic fraction. As you can see in the hexagons below or on the screen, you will notice that you are given an algebraic expression. You may not know what an algebraic expression is, but an algebraic expression is a combination of algebraic terms, either by addition or subtraction or multiplication or division, or it could be an algebraic term in combination with a number, as we can see in this case 5x minus 3. We have 5 being the coefficient there, x is a variable, 3 being the constant, and we have 5x minus 3 being the algebraic expression. This is a whole algebraic expression, and it can become an algebraic fraction when divided by a number or another algebraic term or expression. An example is when you use 2y to divide it. So 5x minus 3 over 2y gives you an algebraic fraction. 5x minus 3 over 2y is an Now, from our objective at the beginning of this lesson, we said we want to be able to identify algebraic fractions. Now, algebraic fraction, let's look at the examples now. Examples of algebraic fractions. And that is why you can have 2c over EF. You can say it's an algebraic algebraic fraction 2c over ef, 8u plus 8v over 6u plus 6v is also an algebraic fraction. X plus y over 6 is also an algebraic fraction. And like any fraction, the upper part is called the numerator and is written above the lower part called the denominator. And I want to believe that by now you should be able to start developing your Now, it's time to simplify algebraic fractions, and I hope you are enjoying the lesson. Okay, what does it mean to actually simplify algebraic fractions? Like any other fraction, for example, you are given 4 over 16. 4 over 16 is not in its simplest form. So we need to simplify further by dividing by 2 or by 4 to give us 1 over 4, which is the simplest fraction that cannot be divisible again. Just in the same manner, an algebraic fraction can be simplified such that no value in the numerator or no expression in the numerator can cut or divide any expression in the denominator. You bring it to its lowest form. So to simplify algebraic fractions, we need to factorize both the numerator and the denominator, which makes it impossible to cancel out the common factors. This is not for every case, because some expressions can actually be divided if there is no need for factorization. Thank you. Alright, let's continue simplifying algebraic fractions. At this juncture, we are going to look at some examples and see how easy it is to simplify algebraic fractions. You might be wondering, is it possible to actually simplify these chunks? Yes, you can. You can simplify these algebraic fractions. The first one is xyz or xyz over wxz. The second one, which looks so cumbersome, don't be scared, 12a squared bc over 144ab squared c squared. C, we have p squared plus pq over p, and we have d pq squared minus q over pq. Now all these together, we are going to simplify them in the next slide. Okay, to simplify algebraic fractions, we have been told in the previous slides that we need to factorize either the numerator or the denominator or both. But at times, you may not need to do any of this because it is easy to divide the given expressions. Like the examples in A and B, you have in A, xyz over wxz. In this case, xyz is the same as x times y times z over w times x times z. And when you cut out, x cancels out x, and then z cancels out z, and that gives you y over w as the final answer, which is the simplified algebraic fraction that you now have. Also in the second one, which is b, 12a squared bc over 144ab squared c squared. This gives us, when we expand it, 12 times a, that is a squared, times b times c over 144 is 12 times 12 in a way. There are other ways we can write this. Then a times b times b times c times c, and that gives us a over 12 times b times c when you cancel out the common factors. So the final answer is a over 12 bc. So you will note that this example above is straightforward. There is no need to factorize in both cases. Now, the slides to come will show us an example or examples where we need to actually factorize the numerator or the denominator or both. Let's go together. Alright, before we move into the other two examples, C and D, I want to be sure you understood the examples we did in the previous slide. Therefore, you may want to try the following exercises, which says reduce the following to their lowest terms. Note that these exercises above are straightforward too, so there is no need to factorize. You may want to try it. Thank you. Wow, I'm enjoying the class. I don't know if you are really following, but I'm actually enjoying this class. Now let's try and simplify the third example and the fourth one. The third one, which is example C, it says to simplify p squared plus pq over p. The first thing you need to do is to actually factorize the numerator, which will give us some problems when we try to divide. So when you factorize p squared plus pq, you have p, open bracket, p plus q, then close the bracket. This is the factorized form of the given quadratic expression in the numerator. Then when you rewrite this, you have p squared plus pq over p is equal to p into p plus q over p. Now p can see p to cancel out, and that means we are left with p plus q, which is the final, like the previous one. Now let's try it. pq squared minus q over pq. Just like the other one too, we need to simplify the numerator. And when you do that, pq squared minus q will give us q, which is the common to both expression on both sides of the divide, and then into bracket pq minus 1, then close the bracket. This is a factorized expression of the given expression in the numerator. Therefore, pq squared minus q over pq is equal to q, open bracket, pq minus 1, close the bracket, over pq. Now it is now easy to be able to cancel out q and q, which gives us pq minus 1 over p. Note something, however, that p in this final expression cannot cancel p in the denominator. The p in the numerator can't cancel the 1 in the denominator because it is associated with the minus 1. So you can't just cancel out to give you q minus 1. No, that would be very wrong. So the final answer is pq minus 1 over p. Thank you very much. I haven't gone through examples 1 to 4. I think it is now easy for you to go through this and try them on your own. You have to simplify the following. I want to believe that in number 1, you should know you need to factorize. In number 2, you need to. Number 3, the same, and number 4. So it will be easier when you try to do this on your own. Be sure you let us know how interesting this is. Thank you very much. With this we have come to the end of this presentation, though it's not the concluding part yet. The concluding part will soon be out. Make sure you subscribe to this YouTube page so that you can always get it when it is out. And having gone through identifying algebraic fractions and simplifying them, don't let it end there. Pick up some textbooks, check some other examples, solve them, and then be sure that you are a master of what you do. Now keep on practicing.